Hello everyone, I hope you're doing well. Let me introduce myself.
Behold the math sorcerer.
Today we are going to solve a very interesting problem. If we have root xyz equals to b to the power bc into root over cd by a whole by a, where a, b, c, d all are primes, then find the value of a to the power c minus bd. Okay, so xyz must fulfill the following conditions. Xyz are positive real numbers. X plus y plus z equals to 48 and root over 144 minus x square plus root over 400 minus y square plus root over 784 minus z square is equal to 36. So these are the three conditions that we must abide by, and then we have to solve for xyz, and then we have to solve for abcd. Okay, I hope uh, you could take a screenshot right now, this part and this next part. Do try the problem by yourself. It is a fun problem. I'll start the solution in 1, 2, 3. Okay, let's go. So what we are given, and root over 144 minus x square. Okay, 144 is 12 square. Let's write it like that. Then we had 20 square minus y square plus, then we had 784. Let me just do the square root. That's probably 28. Okay, it's 28. 28 square minus z square is equal to 36. And xyz all are positive real numbers. They are not even 0. They are greater than 0. Okay, so there was a hint in the beginning. This whole series is dedicated to geometry. We are supposed to find geometry in places where we don't expect them. So where is the geometry? Well, if I had 12 as hypotenuse and x as base, then this will be the height, or you can say if this is the adjacent length, this is the opposite length or something. Okay, so same goes for this part. Let's visualize it. So if we had, let's use green because I am a green flag. Suppose we had this. Okay, so I am saying that some part of this is x, some part of this is y, some part of this is z, and the total is 48 as per the conditions. And we have a hypotenuse which is 12, another hypotenuse which is 20, another hypotenuse which is 28. And if we observed carefully, 48 and 36. Okay, 48 and 36. There is something very fishy about them. I have talked about
3, 4, 5 right angle triangle in many of my videos. And if you observe carefully, this 36 is the 3 here.
I mean, if we do 36 square plus 48 square, we'll get 60 square. And adding 12 plus 20 plus 28 gives us 60. Okay, I guess very few people could have got the hint. Let me give you a clearer picture. Let's say we have a hypotenuse of 60. Okay, this is 60. then we would have had a base of 36. Okay, so how does that help? Let's say this part, some part of this is 12, some part of this is 20, and some part of this is 28. So this is the part. Then let's say this part is y. So this is the part. Let's say this part is z. So this is the part of like base. Okay. What I mean to say is this is 12 square minus x square. This is 20 square minus y square. And this is 28 square minus z square. Well, we can just like I can shift this line below. This will be exactly root over 20 square minus y square, and this part will be exactly root over 12 square minus x square. So this total part, it equals to 36. This total part equals to 48. This total part equals to 60. So everything should make sense right now. These are just lengths of uh, three triangles. They are just lengths. I just added three lengths here. Length, length, lengths. Okay. And I added another three lengths here. And there were three hypotenuses hidden here. Okay. So now what? We can use similarity of triangles to solve this problem. We can use anything else. It doesn't matter how we are using it. Let's say for now, x divided by 12 will be equal to y divided by 20. Let's say we are taking a sine alpha. Okay, so this is the sine alpha, right? This is alpha, this is alpha. The whole triangle has this alpha. So sine alpha means opposite by hypotenuse. So this is valid for all of these 28, and if we add all those up, we will have x plus y plus z, which is 48, and in below we will have 60. So from here we can easily solve for x, y, z. So now we have the values of x and y and z. So the next part is quite easy. I mean, I'll just have to multiply them, then take the square root. I can do that using a calculator. Okay, I got 64 root 21 divided by 5, and I can write 64 as 2 to the power 6. That can be written as 2 into 3, and this can be written as 3 into 7. By comparing with the b to the power bc root over cd by uh, a equals 5, b equals 2, c equals 3, and d equals 7. So the desired answer that I was hoping, a to the power c minus bd, which is 1, 1, 1. I know this isn't the easiest problem in the whole world. The first visualization part that actually takes, I mean, I don't know what it takes. You have to solve similar problems, I guess, to actually think of one by yourself.
Thanks for watching.
Subscribe our channel.